Well, by this time you know that electronic conductors are something which conduct the electric current through relay of electrons. Electrolytic conductors are those which conduct electric current due to movement of ions. And of course, you know that an electrolyte is a liquid or a solution or a fused mass that permits the conductance of electricity through it. You also know that metallic wires, mercury, cadmium sulphide, etc., which conduct current through the relay of electrons, are known as electronic conductors. And if I take sodium in liquor ammonia, which makes a deep blue solution that conducts electric current both through the movement of electrons and also through the movement of ions, because it contains sodium ions, free electrons in that solution which has deep blue color. All these ideas you know that. You also know that any liquid or solution or a fusion mass that conducts electric current is electrolyte. And an electrolyte can be strong electrolyte which has a large number of ions like strong acids, strong bases, and the salt solutions made by either of those. All they are very strong electrolytes. Weak acids like acetic acid, tartaric acid, they are weak electrolytes. Ammonium hydroxide is a weak electrolyte. And you also know that by this time, an electronic conductor, something like this, its conductance or resistance are adversely affected by rising temperature. The resistance greatly increases for electronic conductor on heating, whereas for electrolytic conductor on heating, resistance drops. You also know that electronic conductor is not involving any material transfer during the conductance, whereas in electrolytic conductor some movement, material movement, mass transfer is there. And you know, cations which have positive charge during the electrolytic conductor go to cathode, and cations which have positive charge lose their charge by gaining electrons. Therefore, you know that at cathode there takes place reduction, and anode, the negative ions like Cl minus, when passed through current in aqueous solution, lose their negative charge, and at anode there happens oxidation. And during the process where you pass current, the electrolyte dissociates. A reaction which is non-spontaneous happens because you are passing the electric current. This is the electrolytic conductor. Hopefully you know that there are many cells like Downs cell, for example, where molten NaCl is electrolyzed to get sodium metal. Nelson cell is there, where you are trying to make something like NaOH by passing current through aqueous NaCl solution. All that you know. Now, in this brief session, what we want to see is when you pass current through an aqueous solution through platinum electrodes, if this aqueous solution is containing ions like copper plus 2, Ag plus, you also have something like Zn plus 2, and you have sodium plus. All these are cations, and you have anions like the chloride ion, the bromide ion, the sulphate ion, etc. When you are passing electric current through a solution that contains all these ions, you need to know actually what happens, which is deposited. You know, all the cations are deposited at cathode. Cathode is a negative terminal, and all the anions are deposited at the anode. Anode is a positive terminal. And now you want to know, out of all these ions, which is deposited first. Because you know clearly when you are passing current, positive ions lose their positive charge by gaining electrons. For example, copper plus 2 can gain 2 electrons to become copper. But the solution also has Ag plus, which can gain 1 electron to give Ag. Now in these two, which wins the race? Now I would suggest that you know about electrochemical series, where standard reduction potentials are measured, and with respect to hydrogen, standard hydrogen electron. The point is, whatever that has high reduction potential is deposited first. Therefore, silver with highest reduction potential is deposited first. Then chance goes to copper. Now if you look at sodium, the reduction potential of sodium is very low. In fact, first group, second group metal ions reduction potentials are so low. In fact, water also tries to grab an electron to become OH minus and half H2. This reaction electrode potential is much greater than the standard reduction potential of sodium, potassium, calcium plus 2, so on. Therefore, in the race, sodium, potassium, first group metal ions, second group metal ions, they are even aluminum plus 3, they never can take electrons because water preferentially takes electrons as its reduction potential is higher. As you know, high reduction potential fellow is reduced first. So water grabs the electron, OH minus is released. No effect is there for sodium, potassium, calcium, aluminum ions if they are subjected to electrolysis in aqueous solution. So higher reduction potential fellow is reduced first. Now what happens at anode? You can also say high oxidation potential fellow is oxidized first. To avoid confusion, internationally we are taking only reduction potentials. So if you look at reduction potential point of view, high reduction potential fellow is reduced first. Low reduction potential fellow is oxidized first. Now in this list, chloride, bromide, if you take, the fellow which has lower reduction potential is bromide ion. Therefore, preferentially bromide ion loses the electron at anode to give you the bromine and 2 electrons. Okay. Now, in this case, whatever that has lower reduction potential is reduced first. If your solution is having fluoride ions and fluoride ions reduction potential is very high, right? Now our idea is what? High reduction potential is reduced first, low reduction potential is oxidized first, right? Because the fluorine has very high reduction potential, it is never oxidized, right? If you look at sulphate ions, nitrate ions, their reduction potentials are high. They are never oxidized at anode. In fact, water is in competition to undergo oxidation. If water is getting oxidized, it will give you 4H plus and O2 plus 4 electrons. 4 electrons. Now in this course, what happens is the sulphate ion, nitrate ions have higher reduction potential than water. Therefore, because water has lower reduction potential than the sulphate and nitrate and phosphate, etc., these ions are never oxidized in aqueous solution. It is water that is oxidized to give oxygen. This is the idea you should have. Now you will be wondering, sir, if I take a solution that contains sodium sulphate in aqueous solution, what happens? If you take sodium sulphate in aqueous solution, sodium is not going to undergo reduction because its reduction potential is very low. Therefore, water is preferentially reduced to give you hydrogen gas. Okay, you can see that like this. 2 electrons are gained to give H2 plus 2OH minus. So Na plus is not changing. In fact, water is undergoing reduction to give OH minus ions. So at a cathode, sodium is not undergoing any change. Keeping quiet, Na plus will join with OH minus to make the solution basic at the end of the cathode. Now at anode if I see, again the sulphate ion reduction potential is higher than that of water. Therefore, the lower reduction potential is there for water. So water is preferentially undergoing oxidation but not sulphate. Therefore, water will undergo the so-called oxidation to give you 4H plus and O2 and 4 electrons. Therefore, at this end of anode, you are getting H plus ions. And nothing is happening to sulphate ion. Hence, sodium is not affected at cathode. Sulphate is not affected at anode. Only water is affected at both ends. So eventually, the solution is becoming more and more concentrated with Na2SO4. This is the fate of the electrolysis of solutions like sodium sulphate, potassium sulphate, sodium phosphate, potassium phosphate, so on and so forth. So the criteria is fellow with high reduction potential is reduced first at cathode, fellow with high oxidation potential or fellow with low reduction potential is oxidized first at anode. This is the criteria of product formation when you take inert electrodes like platinum and pass the electric current through aqueous solutions. That's all for now, folks. Thank you.